Good afternoon, students. So I'm going to go over quiz 2 right now. Please make sure that when you get your quiz back tomorrow that you do the corrections on it. So the first one says, name the angles in the diagram below. Okay, so here are the angles here, and they want me to name them. So let's name them. So this could be 3 angles anyway. So we're going to say angle WZXY. Could also say angle YXW, just kind of flipping that around as long as X stays in the middle. We could also go with angle YXZ and also flip that around, angle ZXY. And you could always still say angle X, which would mean the entire angle here, that entire angle. Number 2. Use the protractor to find the measure of the angle ABC here. So I actually took a protractor and measured this angle just to kind of look and see how big it was. If we were to make this a straight 90-degree angle, we could see that this would be about 90. So as long as you have something between 40 and 50, you got credit for this. But this is around 45 degrees. Number 3 says use your protractor to draw angle DF when it is an 80-degree angle. So again, if you were to construct an angle that was 90 degrees, then an 80-degree angle would be a bit smaller, not much, but a bit. Okay, so you need to put on that DEF, and there we have DEF. All right, number 4. Use the protractor to figure the measure of the indicated angles and then classify the angle according to its measurement. Okay, so MI, measure of angle IKJ. Here's IKJ. Okay, this angle is pretty small. It's part of a right angle, so it actually turns out to be 30 degrees. Angle GKI. This angle is actually bigger than 90, but he added. So now it looks like this angle is going to total about 150. Again, because we're adding the right angle and this other angle here, and together they form this 150-degree angle. So now we've got the measure of angle GKJ, right? And this, again, is a straight angle, so this is going to be 180 degrees. And then D says the measure of angle GKH. And we see right there that that looks like it's a right angle, and it is. So let's actually just write those in really quickly. And there we have it, acute, obtuse, straight, and right. Okay, number 5. Okay, so this problem says label the diagram below if the measure of angle RVS is 40 and SVT is 30. What is the measure of RVT? So this basically is using that thing we calling the angle addition postulate. So angle addition postulate. And that basically says that if you have 2 smaller angles that are put together to make a larger angle, then you can actually add them together and set it equal to the larger piece. And that's what we've actually written here. This is an example of angle addition postulate. So let's actually substitute in what we know. We know that RVS is 40. I'm going to put 40 here because that's what RVS is. And then we're adding. We know SVT is 30. So that means that 40 plus 30 gives us our angle RVT, which is 70 degrees. Okay, our next problem says, given that the measure of LKN is 145 degrees, find LKM. So we know that these 2 angles here add up to this bigger angle, LKN. And we know that LKN is 145, so we need to just literally substitute what we know. L2x plus 10 plus this 4x minus 3 is all going to equal 145 degrees. So if we go ahead and simplify this here and solve it, x is going to equal 23, which means that the measure of angle LKM, if we substitute in 23 for x, is going to give us 56 degrees, and that is our solution. The last question is problem number 7. And problem number 7 simply says angles that have the same measure are congruent. All right? So we know how to write that. This is a symbol, and the word is actually congruent. Okay, so our video is a little long today because we have to review the quiz. But again, make sure you review the quiz. So this is video 1.7. This is Tools of Geometry, and your objective today is I can find the midpoint of 2 segments. The skill that you should be working on is not just B8 now, but it should also be B7. B7 is also a skill that you should be able to work on and complete. Okay, so the midpoint. A midpoint, again, you're writing this down. Midpoint is going to be a segment that divides the segment into two congruent segments. So if I have a line, AB, and then on that line, AB, I have segment AB. I'm going to highlight segment AB in blue. Here's segment AB, and it's from this point to this point. And if I wanted to figure out what the midpoint of this segment would be, I'd have to cut this into two equal pieces. So let's do that. Create a point here. And this point would be point M. We'll call it point M. And now this means that AM is going to be congruent to MB. So segment AM is now congruent to segment MB because M is the midpoint. Important to remember when segments with congruent lengths are congruent segments. Okay, very important. So while we say segment AM is congruent to segment MB, we also could quantify that and give it numerical values. If we were to actually measure it out and say it back up here, if AM was 4 and this piece over here was 4, then we'd actually be able to talk about how the measures of those lengths would actually be the same too. Okay, let's try an example. And this is an example actually from my Excel where we're finding the distance between 2 points. The first point is 12, 0, and the second point is 0, 5. So I'm actually going to draw on the vertical here. And it looks like the vertical is a distance of 5. I'm going to draw on the horizontal. Which we clearly see is a distance of 12. Then I'm going to use Pythagorean theorem to figure out that other side, that hypotenuse I don't know, which turns out to be my missing side. Pythagorean theorem, I'm going to plug in what I don't know. The two legs I know, so I've got 5 squared plus 12 squared equals c squared. And I want to just simplify it. Here with 169 equals c squared, and I want to take the square root of both sides. If I do that, I'm going to end up with c equals square root of 169 is 13. So that means this length, the distance, shortest distance between the 2 points is 13. Now again, you could have used the distance formula, but again, I feel like this is just a method that's going to be easier and definitely helps you understand the problem better. Okay, so now let's move on to midpoint, our new topic for today. So the midpoint again is going to be that point that creates two congruent segments within a segment. So if we know the end point is at -4 and the other point is at 9, I want to take these 2 points, these 2 numbers, -4 plus 9, and I want to add them together. And I want to divide by 2 because I want this right in the middle. So that's going to give me 5 over 2, which turns out to be 2.5. So that means the midpoint for this segment that is just horizontal is going to be 2.5. So somewhere right about here. Somewhere about there. How about that? Well, now let's look at a segment that has it on an x and a y axis, not just an x axis. So let's first figure out the points A and B. So now if we look at the coordinates of A is at -9, -6, and B is at 6, 6. So I want to now add the x values and divide by 2. I'm going to do the same thing with the y values. Now I have both coordinates of the midpoint, the x and the y. The x is simply going to be that -3 over 2. And the y is whatever 0 divided by 2 as well. 0 divided by anything is just 0. So this is the coordinate of the midpoint. Let's put it in. It appears to be right at this blue dot. So here's example 4. Example 4 says the midpoint of CD is M, -2, 1. And they were giving you an endpoint. An endpoint is -5, 7. So that's here. So you're getting an endpoint and a midpoint. And it says, well, what's the coordinate of the other endpoint? So we did it traditionally. We'd actually plug in the x's, the y's, and we find the midpoint, the x and the y. But now we have to kind of work backwards. I'm going to plug in what I know. So I know very clearly that -5 is the x coordinate of one of the endpoints. So I'm just going to put that in because that's what it says to do. But I don't know the other endpoint, right? It's missing. So I'm just going to leave that as x sub 2. but I know the midpoint's x value is -2 because it's right there. So that's what we would normally get. This is what we already have. So now what's missing is just the x of 2. And I'm going to cross multiply in a minute to figure out what that is. And I'm going to do the same thing for the y. I know the y1, one of the endpoints is, well, 7. I'm going to plug that in. I don't know the other endpoint it's missing. And then I'm going to plug in my y midpoint value. The midpoint of the y coordinate goes here. And then I'm going to cross multiply in a moment to figure that out. So if I just put this over 1 here and put this over 1, you can do that so that you can cross multiply. So here I've cross multiplied. -5 plus x2 times 1 just gives me that. And then -2 times 2 is going to give me -4. Now I want to solve for x of 2. Now I know that one of the endpoints coordinates is going to be 1, and that's the x. So this is actually going to be at 1. Let's see what the other one is. Cross multiplied again. Now I'm going to just subtract 7 from both sides. It appears that we get -5. So this is going to now be -5. So the coordinate of the other endpoint is 1, -5. So if we were to actually look at it practically and try and figure out where is 1, -5, 1 over 1, down 5, about right there. And it looks real, like that actually makes sense. Like if these 2 points were the endpoints, then that would be the midpoint of the segment. Okay, so here's a secret hot question. It says, hey, on a zip line course, if you've ever been camping on a zip line, it's so fun. You're harnessed to a cable that travels from treetop to treetops. You start at platform A, and platform A is actually right here, okay? And you're zipping to each of the platforms. Well, how far do you travel from B to C? So if you want to find B and find C, I'm going to give you a hint here. You want to figure out what the points are. What is the point here? What is the ordered pair, the coordinates for B and for C? And then you literally want to find the midpoint. Remember to record your secret answer on the Google Doc. Have a great night.